Hi, I'm Miss Roger, and welcome to Core Concepts in Algebra 2. Today's lesson is going to be on graphing quadratic functions. The Massachusetts curriculum frameworks for mathematics are tied to this lesson, specifically ACED, creating equations, and FIF, functions interpreting functions. Today's lesson objectives: to graph quadratic functions written in vertex form, y equals a parentheses x minus h close parentheses all squared plus k, and to graph quadratic functions written in standard form, y equals ax squared plus bx plus c, and to identify key points on the graph of a parabola. Let's take a look at the first problem. Y equals parentheses x minus 1 close parentheses all squared plus 3. This equation is in vertex form. So the first step is going to be to plot the vertex. Our vertex comes from the point h comma k. So our vertex is the point h comma k. We're going to identify the vertex from our original equation. So our vertex for this problem is 1, 3. The reason why it's positive 1 is because of the original form being x minus h. Once we have our vertex, we're going to plot that point. The next step when graphing parabolas in vertex form is to identify if the parabola is going to open up or open down. Our a value is going to control this. If the a value is positive, the parabola is going to open up. If the a value is negative, the parabola is going to open down. Here, our a value is 1. The next step is to gather more points on the graph. To do this, we build a table. The best way to do this is to pick 2 points either to the left or to the right of the vertex. Since our vertex is the point 1, 3, we can either pick 2 and 3 or we can pick 0 and negative 1. I'm going to select 2 and 3. Next, we take these points and put them into the original equation for x and solve for y. So if I take 2 and I plug it in for x, 2 minus 1 is 1. 1 squared is 1, 1 plus 3 is 4. For 3, 3 minus 1 is 2, 2 squared is 4, 4 plus 3 is 7. These are two ordered pairs on my parabola, 2, 4, and 3, 7. I'm going to plot both of these points. 2, 4, and 3, 7. Right now, as you can see, I have half of my parabola. Something interesting about parabolas is they are symmetric. They are symmetric about the x point of the vertex. So we're going to identify the axis of symmetry. The axis of symmetry is always x equals h. So for this problem, it's going to be x equals 1. The axis of symmetry is a vertical line in which you can reflect the points that you've plotted. So I'm going to reflect. I'm going to go 1 over in the other direction and plot my next point. I'm going to go 2 over to the left and plot that point. And I'm going to connect all of the points with a smooth curve. In order to indicate that the parabola is going to infinity in both directions, you use arrows. This is the graph of my parabola, y equals x minus 1 all squared plus 3 in vertex form. So to recap the steps, first thing is to identify the vertex, which is always h, k. Once you have the vertex, you plot that point. The next step is to identify if the parabola opens up or opens down based on the a value. If the a value is positive, the parabola opens up. If the a value is negative, the parabola opens down. The last step is to build an XY table, selecting 2 points to the left or 2 points to the right. Once you've selected these points, you plug them into the original equation for x and solve for y. Understanding that parabolas are symmetric, you reflect the points using the axes of symmetry. This is the graph of a parabola in vertex form. Let's take a look at another equation in vertex form. So we're going to use the same equation, y equals a parentheses x minus h close parentheses all squared plus k. Let's identify the vertex, which is h comma k. In this problem, we're going to have -4, -2. Again, remember your h point is always going to be the opposite. So there, it's +4, so here it's going to be -4. And the reason that is because of our original form, x minus h. So that meant that h was negative, since we have a positive in our vertex form. Now let's identify if our parabola opens up or down based on our a value. Our a value is -1/2, so that's going to mean that our parabola opens down. And again, notice how these parabolas are U-shaped. Let's plot the vertex. For this problem, I'm going to use -6 and -5. When I substitute -6 in for x, -6 plus 4 is -2. -2 squared is 4. 4 times -1/2 is -2. -2 minus 2 is -4. Let's substitute -5 in for x. -5 plus 4 is -1. -1 squared is 1. 1 times -1/2 is -1/2. And -1/2 minus 2 is -2.5. Now I can plot these ordered pairs. -6, -4, and -5, 2.5. So again, I have one leg of my parabola. And to get the other leg of my parabola, which it's symmetric about, I find the axis of symmetry. Here, the axis of symmetry is going to be x equals -4. Now that I have the axis of symmetry, I can reflect my points. Here I went over 1 to the left, so I'm going to go over 1 to the right and reflect. Here I'm going over 2 to the left, so I'm going to go over 2 to the right and reflect. This is the parabola for y equals -1/2 parentheses, x plus 4 close parentheses, all squared minus 2. So, we just finished graphing vertex form. Now we're going to take a look at graphing standard form. There are two forms of a quadratic equation, vertex form and standard form. So let's take a look. This is our standard form equation. We're going to graph y equals 3x squared minus 6x. So the first thing that I want to do is identify my a, b, and c values. The coefficients in front of my x squared, my x, and my c value are going to indicate which values these are. So for this problem, my a is 3, my b is -6, and my c value. Here, my c value is 0. My next step is to find the vertex. I want to locate that on my graph. So there's an equation. X equals -b all over 2a. So we're going to use the a, b, and c values in order to find the x point of the vertex. For this problem, using the equation h equals -b all over 2a, h equals 1. The last step is to find the k value. In order to find the k value, we're going to substitute our h value of 1 into the original equation for x and solve for y. When I substitute 1 in here, which is my h value, my y value, my output, is going to be my k value. Now I have an ordered pair for the vertex. My vertex is 1, -3. Let's plot the vertex. My next step is to understand if it opens up or down based on the a value. Here, my a value is 3. So this parabola is going to open up. Let's build a table. Let's select 2 points to the left or 2 points to the right. In this case, let's use 0 and -1. -1 squared is 1. 1 times 3 is 3. -6 times -1 is 6. So here, y is going to equal 9. Let's plot that point. Let's try 0. 0 squared is 0. 0 times 3 is 0. -6 times 0 is 0, and 0 minus 0 is 0. Wow, that's our y-intercept. In order to reflect, we use the axis of symmetry. The axis of symmetry is always in the form x equals h. Here, our axis of symmetry is x equals 1. Let's reflect our points about the axis of symmetry. We're going to use a smooth curve to connect the dots. This is a parabola for y equals 3x squared minus 6x in standard form. Let's take a look at another problem in standard form. For this problem, let's identify our a, b, and c values. For this one, we're going to have a as 2, b as 4, and c as 5. Using our formula for h equals -b all over 2a, we can find the x point of the vertex. For this problem, h equals -1. Let's find our k value by substituting -1 into our original problem. When we substitute -1 into our original problem, we get this. Let's solve for k. Our k value is going to be 3. So our vertex is -1, 3. Remember, the a value determines if the parabola is going to open up or open down. In this case, the a value is 2. so our parabola is going to open up. Let's plot the vertex. Let's build our table to get additional points on the graph, either 2 points to the left or 2 points to the right. Remember, the only reason why we have to select 2 in our table is because parabolas are symmetric. Thus, we can reflect about our axes of symmetry. Let's use 0 and 1. When we substitute 0 in, 0 squared is 0, 0 times 2 is 0, 4 times 0 is 0, plus 5. 0, 5 is one ordered pair on the graph. Let's substitute 1 into our equation. 1 squared is 1, 1 times 2 is 2, 4 times 1 is 4, 4 plus 2 is 6, 6 plus 5 is 11. 1, 11 is a point on our graph. The axis of symmetry is always x equals h. This is a vertical line. For this problem, it's x equals -1. Let's reflect our points to get the other branch of the parabola. This is a parabola in standard form of y equals 2x squared plus 4x plus 5. What are the advantages of a quadratic equation in vertex form versus standard form? How is any quadratic function related to the parent function, y equals x squared? And when given a quadratic equation, how do you know if the vertex is a maximum or a minimum point? These essential questions we're going to discuss during class tomorrow. Please start to think about them tonight. After watching today's video on graphing parabolas in quadratic functions, try these. Sketch the graph of each function. The first one is in standard form and the second one is in vertex form. Use the guided examples to help you. Identify the vertex in the axes of symmetry of number 3 and 4. Number 3 is in standard form and number 4 is in vertex form. Thanks for joining me in Algebra 2, Graphing Parabolas. See you next time.